In this episode, we focus on a capability that quietly determines whether cloud security is observable and governable or essentially guesswork: operational cloud logging. Beginners often assume logs are just a technical detail that exists automatically, but in real environments, logging is a design choice, and the absence of good logging is one of the fastest ways to make incidents last longer and cause more damage. Cloud environments are dynamic, meaning systems appear, change, and disappear quickly, and that speed makes it easy to lose visibility unless logging is planned and operated intentionally. Operationalizing logging means you do more than turn on a few settings. You build a reliable pipeline that collects the right sources, normalizes data into consistent meaning, retains it long enough for investigations and compliance, and produces alerts that are high quality rather than noisy. The title words are not separate topics, because each one depends on the others. If you collect sources but do not normalize them, you cannot correlate events reliably. If you normalize but do not retain, you cannot investigate long-running incidents. If you retain but alert poorly, you drown in noise and miss real threats. Our goal is to explain these concepts in a way that makes them feel practical to a beginner and shows how they fit together into a mature cloud security posture. A good starting point is to understand what logs are in cloud security terms, because they are broader than just application error messages. Logs are records of events, and in cloud environments, the most important events often involve identity, configuration, and data access, not just crashes. Some logs record who did what, such as administrative actions taken through the cloud control plane. Other logs record what a workload did, such as authentication attempts or network connections. Some logs record system behavior, such as service health, errors, and resource usage that can indicate disruption. Beginners should notice that cloud incidents often involve a sequence of actions, like an attacker using a stolen credential to create access, then accessing data, then modifying settings to hide evidence. Without logs that capture these actions, you cannot reconstruct the story, and without the story, you cannot respond confidently. Logs also support governance because they provide evidence that controls are being used, such as whether MFA is being enforced or whether privileged actions are occurring unexpectedly. Another reason logs matter is that in cloud systems, many critical actions happen through APIs, and those actions can be invisible unless control plane logging is enabled. Operational logging is therefore about capturing both the management layer and the workload layer. Once you see logs as the record of reality, you can understand why cloud security depends on them. The first component in the title is sources, and sources are the places where you collect logs from, which must be chosen deliberately. Beginners often think one log source is enough, but cloud security requires multiple perspectives because no single source tells the whole story. A key category is identity and access logs, which show authentication attempts, role assumptions, and permission-related events, because cloud access is identity-driven. Another category is control plane logs, which show administrative actions like creating resources, changing network rules, or modifying access policies, because those actions can change the security posture quickly. Workload and application logs are another category, because they show what the systems did internally, such as unusual errors, suspicious requests, or changes in behavior. Network flow and connection logs provide visibility into how systems communicate, which can reveal scanning, unexpected outbound connections, or unusual internal movement. Data access logs for storage and database services are also important when sensitive information is involved, because they show when data was accessed and by whom. Beginners should recognize that source selection is a risk-based decision. You prioritize sources that reveal high-impact actions and high-value asset access. If you choose sources randomly or minimally, you create blind spots that attackers can exploit. Operational logging begins with knowing which questions you will need to answer during an incident and ensuring the sources can answer them. Choosing sources also requires understanding the difference between breadth and depth, because collecting everything without a plan can be expensive and still fail to produce useful visibility. Breadth means capturing major categories so you can see identity, management actions, network behavior, and data access across the environment. Depth means capturing enough detail in each category to support investigation, such as timestamps, actor identity, target resource, and action outcome. Beginners should notice that the wrong kind of logging can create false confidence, such as having a control plane event record that lacks enough detail to identify what resource was changed. Another challenge is that cloud services generate different log formats and levels of detail, which makes it easy to enable logging but hard to use it effectively. This is why operational logging requires a plan for coverage, not just a list of services. Coverage also includes ensuring logs exist for all relevant environments, because logging only in production can miss reconnaissance and testing that occurs elsewhere. Another subtle point is that logging sources must be resilient to tampering, because attackers may try to disable logging or delete evidence. While beginners do not need to design every technical detail, they should understand the governance principle that high-value logs should be protected and centralized. Good source selection is the foundation on which all later steps depend. Normalization is the next key idea, and it is the step that turns many different log formats into consistent meaning. Beginners often assume logs are readable as is, but when you collect logs from many sources, the same concept can be expressed in different ways. For example, one service might call an identity field user, another might call it principal, and another might embed it in a nested structure. If you do not normalize, your searches and alerts become brittle because they depend on source-specific details rather than on shared concepts. Normalization maps events into a common structure, such as consistent fields for who, what, when, where, and outcome. It can also include consistent naming for event types, so authentication failures, privilege changes, and data access events can be compared across systems. Beginners should realize that normalization is not just about making data pretty. It is about making correlation possible. Correlation is the ability to connect related events into a story, such as an authentication followed by a privileged action followed by a sensitive data access. Without normalization, correlation becomes a manual, error-prone process, and an incident response. Manual and error-prone means slow. Another benefit is that normalization supports consistent dashboards and reporting, which helps leaders govern risk and detect trends. Operational logging becomes more powerful when normalized data creates a shared language of events. Normalization also involves time, because timestamps must be consistent or investigations become confusing. Cloud environments span regions and services, and logs might use different time zones or different timestamp formats. If time is not normalized, you can misinterpret sequence, which is dangerous because sequence often determines meaning, such as whether a privilege change happened before or after a suspicious login. Beginners should notice that time confusion is a common incident investigation problem, and normalization is how you prevent it from derailing response. Normalization can also include enriching logs with context, such as adding information about which environment a resource belongs to, what sensitivity level it has, or what team owns it. This context helps analysts prioritize alerts because they can see whether an event touches a critical system or a low-risk test environment. Enrichment must be done carefully because bad enrichment can mislead, but when done well, it increases alert quality and reduces investigation time. Another important point is that normalization and enrichment should be consistent over time, because changing the meaning of fields midstream breaks trend analysis and complicates investigations. Operational logging is a long-term system, so stability matters. When normalization is handled well, the organization can treat log data as reliable evidence rather than as a pile of unrelated text. Retention is the third major component, and it is about how long logs are kept and in what form. Beginners often assume retention is a compliance detail, but it is also an operational necessity because many incidents are discovered late. Attackers may move slowly, use stealthy techniques, or hide in normal-looking behavior for weeks. If you only retain logs for a short time, you may lose the ability to reconstruct what happened, which can prevent accurate containment and remediation. Retention also supports investigations after an incident, such as identifying all affected accounts and systems, because that often requires looking back across a meaningful time window. Leaders should understand that retention decisions are trade-offs among cost, risk, and legal requirements, because storing more data costs more, yet storing too little increases security risk. A good retention strategy is tiered, meaning high-value logs may be retained longer or stored in higher fidelity, while low-value logs may be retained for shorter periods or aggregated. Beginners should notice that retention also affects detection quality, because some detections require comparing current behavior to historical baselines. If you do not retain enough history, you cannot build or validate those baselines. Retention is therefore part of making your environment observable over time, not just today. Retention must also consider integrity and access controls, because logs can contain sensitive information and because logs are only useful if they can be trusted. If attackers can delete or alter logs, then logs become unreliable as evidence. If too many people can access logs, logs become a privacy risk because they may contain user identifiers, request details, or other sensitive traces. Beginners should understand that logging creates a new asset, which is your security telemetry, and like any asset, it must be protected. Governance should define who can access logs, how access is audited, and what safeguards exist against tampering. Another important concept is immutability, which means logs are stored in a way that makes them difficult to change after the fact. Even without technical detail, the principle is that security logs should be harder to erase than ordinary operational logs, because erasing security evidence is a known attacker behavior. Retention also includes the ability to retrieve logs efficiently, because long-term storage that is slow to search can delay investigations. Leaders should ask whether retained logs can be used in a timely way during an incident, not only whether they exist. Operational retention is therefore about availability, integrity, and confidentiality of logging data over time. Alert quality is the final part of the title, and it is where logging becomes security operations rather than storage. Beginners often think alerting is just turning on rules, but alert quality is the difference between a system that protects you and a system that overwhelms you. High-quality alerts are actionable, meaning they contain enough context to make a decision, and they are meaningful, meaning they represent a reasonable likelihood of real risk. Low-quality alerts are noisy, vague, or repetitive, and they teach analysts to ignore them, which increases the chance of missing real incidents. Alert quality depends on all the earlier steps. If sources are incomplete, alerts miss important actions. If normalization is weak, alerts cannot correlate events. If retention is short, alerts cannot compare behavior over time. Beginners should recognize that an alert is a decision prompt, not a raw event, and a decision prompt must include clear signals about what happened, who was involved, what resource was affected, and why it matters. It must also be tuned to reduce false positives, because false positives waste attention and reduce trust. A mature alerting approach prioritizes high-risk actions like unusual privilege changes, suspicious role assumptions, and unexpected access to sensitive data, especially when they occur in unusual contexts. Alert quality is a continuous improvement process, not a one-time setup. Improving alert quality requires a clear understanding of how analysts work, because alerts must match the realities of triage and investigation. If an alert fires and the analyst cannot quickly confirm whether it is benign or suspicious, the alert becomes a time sink. Beginners should understand that good alerts include the evidence needed to test likely explanations, such as whether the action matches normal behavior for that identity or whether the target resource is critical. This is where enrichment and context help, because the same event might be low risk in a test environment and high risk in production. Another key idea is correlation, where multiple related events are combined into one higher confidence alert, reducing noise and increasing fidelity. For example, a single authentication failure might be common, but repeated failures followed by success and then a privileged action is more concerning. Another improvement habit is feedback loops, where analysts label alerts as useful or not useful and detection rules are adjusted over time. Leaders should see that alert quality is tied to governance, because high-quality alerts require ownership, standards, and time to tune. If the organization never invests in tuning, alert quality decays, and logging becomes a cost center rather than a risk reducer. Operational logging succeeds when alerts drive meaningful decisions. A related issue is avoiding volume theater in cloud alerting, where teams measure success by how many alerts they generate rather than by how well they detect and respond. Beginners should notice that cloud platforms can produce enormous amounts of log data, and it is easy to create many alerts that look impressive and still fail to detect the most important risks. A better approach is to define a small set of high-value detections tied to major risk scenarios, such as misuse of privileged identities, unexpected changes to access policies, suspicious creation of new credentials, or unusual data access. These detections should be tested against real environment behavior and refined so they remain actionable. Another practice is measuring alert outcomes, such as how often an alert leads to meaningful investigation or leads to remediation, because that reveals whether alerting is producing security value. Leaders should also ensure alerts include clear escalation paths and ownership, because an alert without an owner is a warning that will be ignored. Operational logging is therefore not only technical, it is operational design, because it includes who receives alerts, how they respond, and how improvements are made. When alerting is designed around quality, logging becomes a protective capability rather than an endless stream of noise. When you step back, operationalizing cloud logging is about building a dependable evidence system that supports detection, investigation, governance, and resilience. Sources provide the raw visibility, and choosing them intentionally ensures you can answer high-impact questions about identity, configuration, network behavior, and data access. Normalization turns many different log formats into a shared language, enabling correlation, consistent analysis, and faster investigations, while time consistency and enrichment add practical context. Retention ensures you can look back far enough to reconstruct incidents and to build meaningful baselines, and it must include integrity and access controls so logs remain trustworthy and safe. Alert quality is the outcome of doing the earlier steps well, producing actionable, meaningful alerts that guide decisions rather than drowning analysts in noise. For a beginner, the most important takeaway is that cloud security cannot be governed if it cannot be observed, and logging is the foundation of observation. When logging is operationalized thoughtfully, the organization gains the ability to see what is happening, detect what matters, respond with evidence, and improve continuously, which is what strong cloud security looks like in practice.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.